Hi everyone. In this video, we are going to look at exercise 2.6 number 1G, which is part of the homework, which is found on page 148. And here we are supposed to integrate this fraction that we have, which is some polynomials in it. And so for us to do this, first thing is we have to check if we can decompose our denominator further than what it looks like right now. And if you look at that, that is a linear function, so that's fine. And then if I look at that, that is a quadratic function and it is not reducible. Now, if I try to find some factors, they will have to include non-real numbers, and we don't want that. So this would be irreducible or indecomposable, right? And so therefore, using the rules that we have, we can say 8x squared plus 2x minus 1 is over x plus 1. 4x squared plus 1 should be equal to a over the linear factor x plus 1 plus cx plus d over 4x squared plus 1. Here you can use whichever letters you want to use. And from here, now we want to find a, c, and d. So therefore, we are going to say 8x squared plus 2x minus 1 is equal to a times 4x squared plus 1 plus cx plus d times x plus 1. And from here, you can create 3 equations. Since we've got 3 variables, a, c, and d, we want to be able to create 3 equations. And then we'll have 3 equations, 3 unknowns, and then we are able to find a, c, and d. And so I'll skip that part. So if you evaluate, you find out that a is equal to 1, c is equal to 4, and then d is equal to minus 2. Right, so once we get that, then we can substitute that into our fractions there, and then we get that the integral from 2 to 3 of 8x squared plus 2x minus 1 over x plus 1 over times 4x squared plus 1 dx is equal to the integral of, so we substitute our a, and then we because it's 1, we get 1 over x plus 1. This is those are the limits, and then plus 4x minus 2 over 4x squared plus 1 dx. All right, and from here we want to integrate, and we can see that the first one is pretty straightforward. The second one, on the other hand, doesn't look like we can do a direct integration here. So because if we try to do that, if we for example, differentiate the bottom part, we get 8x squared, but it doesn't include minus 2 here. So it seems as if we sort of have to do something else. So what we can do is separate our numerator in this. So we get minus 2 over 4x squared plus 1, and then plus 4x over 4x squared plus 1. And I think with this we are able to find out something. Right, and then so the first one, we know that that's just the natural log of the absolute value of x plus 1. And then the second one, we just have to look at that. So we want to write it in the form 1 over something squared plus 1, and then we know that arctan is involved, and in this case we ought to write it as so the something in here has to be 2x squared plus 1, so we've got something of this nature, right? And that we know that if we have got something like that, then it's going to be arctan of 2x. But because we have got a 2x, it means we have to divide our answer by 2. So we will essentially have 2 over 2 times arctan of 2x. And the over 2 is coming from the fact that we have that if you are to differentiate this, remember this is you have to differentiate whatever is in here first and then differentiate the normal way. So that 2 has to be countered by that 2 so that we have the accurate integral here, right? And so we get that. And then the next thing is to look at that one, the third fraction that we have there. And again, if we differentiate the bottom part, we can see that we will have 8x, right? So in order to cater for that, because here we've got a 4, we have to divide by 2. So we end up with plus the natural log of the absolute value of 4x squared plus 1 over 2. And we are evaluating this on 3 and 2. Right, I hope that is clear how we found the integral here. It's just a matter of making sure that our integral stays accurate by adjusting. Right, and then from here we then say, evaluating, we say this is the natural log of 4. So we are substituting 3 at the moment. So natural log of 4 minus the arctan of 2 times 3, which is 6, plus the natural log of 3 squared is 9 times 4 is 36 plus 1 is 37. So we get 37 over 2. Right, and then minus, now we are we're substituting 2, so we get the natural log of 3 minus the arctan of 2 times 2, which is 4, plus the natural log of 2 squared, that's 4 times 4, that's 16 plus 1, that's 17. So we get 17 over 2. And then from there, it's a matter now of just simplifying so that it looks nicer. And for these 2, we have to get the square root. This is just half of natural log of 37. And we know from the laws of logarithms, let me just write here, a ln natural log of b is just equal to that b times b to the a, right? So if we do that here, we are going to get the square root of 37 and then the square root of 17 there. So we end up with, so another law that we can use is the natural log of a plus the natural log of b is equal to the natural log of a times b. So if I look at that, then I can have this, and that will simply be the natural log of 4 over 3, right? And because we are adding this and we are adding that, we are going to have, sorry, I think I made a mistake here. So here we subtract, and then because here we've got a plus, when we say minus, so we get minus minus, we get plus, and then here we get a minus. So I had made a mistake there. So so we've got 4/3 as our first, and then if we multiply by this, we are using this rule, then we have the square root of 37, right? And then if we subtract this expression, we get square root of 17. So we have that. And then we've got minus the arctan of 6 plus the arctan of 4. And that will be our definite integral there. And that will be our answer. And that is it for this video. Thank you.